All right. Once again, good morning, everybody. Let's start. And people are joining. And I hope everybody can hear me well.
Yes, sir. After watching your videos, I don't have any problem with that.
So after watching the video, you have no question?
Yes, sir. It's more clear to understand the exercise and the solution.
Okay, thank you very much. And from today, I'm going to follow this way, okay? So every Monday and Tuesday, as you know, we have 2 sessions, but 1 session video, I'm going to put this on YouTube. That will be like maybe 2 or 3 videos. Each video will be like around 15 minutes. I try to keep my videos short. Okay, so you have to watch actually during this scheduled time. Okay, this is what I'm expecting. But if you do not watch, and it's your, again, it's your responsibility. And hoping that for the first session, you will watch the video yourself. Okay, and after that, we will continue. 1 session, we will have class together like this. So that during this class, if you have any questions related to the video classes or any problem that you tried but you couldn't solve this, or anything about the quiz, okay. So I will just now continue teaching, but if you have any question, do not be shy. You can just raise your hand, okay, and stop me ask, so I can just stop and discuss your question. Okay, actually about this, feel free, do not be shy, because here nobody can see your face. Some people, even they are shy to show their face, okay. So this chapter is also not a big chapter. It's just what is new for you. Maybe most of you have never learned math in English, okay? You are going to be familiar with a lot of new words. And also, especially the last part, problems leading to quadratic equations. Those questions are not so difficult, but still a lot of students, not only at our university, in most parts of the world, maybe every part of the world, when you just ask a question to solve like equation, they can do this quickly. But when you ask word problems, they have to read, understand, and visualize this, maybe draw a picture, and after that form an equation and solve this. Actually, they face a lot of difficulties. Okay, it's a bit challenging for every student. And that's why word problems, today maybe I'll try to send you assignment questions. You have to try to solve every question here. And also after 2 weeks, you're going to have midterm, right? Starting on May 18. So that's starting May 18. It will be your midterm week, 18, 19, 20, blah, blah. But most probably your midterm will be on May 19, okay? And during the midterm, the questions will come from 4 chapters. That is chapter 4, chapter 5, chapter 6, chapter 7. So you have to practice this question for midterm. So until midterm, you are not going to have any quiz, okay? Now you have to just study for midterm. Midterm, you're going to have at least 20 questions or maximum 25 questions. These are multiple choice questions or short answer required questions, okay? That is about your midterm. Some students ask that are they going to have quiz again or not? No, you are going to have quiz after midterm, maybe in June. This month you will have midterm. Okay. So now today, quadratic equation by using completing the square methods. Okay, we stop here. Now here we are going to learn the general method. Actually, we are going to use this idea to draw the formula to solve any quadratic equation, okay? Before actually we get a formula, we should understand this, what is going on, how we obtain the solution of a quadratic equation. All right, so actually when we are solving the quadratic equation or using these methods, the main idea is we have to bring the quadratic equation into this form. All right. And we know that when we say quadratic equation, we are talking about this equation, right? Here we have ax squared plus bx plus c is equal to 0. Okay. And now, doing some algebraic manipulation, I can transform this into this form. All right. And after once we get into this form, then after that, I can just make x the subject of the formula. Here again, actually making x the subject of the formula because of the square, it's not so easy, right? We just actually did simple examples in the previous chapters, but this one is not that much easy. You should do some, how to say, it requires some skill actually to leave this x alone on the left hand side and express the right hand side in terms of a, b, and c. Okay, so the main idea is bringing into this form. Once we bring this into this form, then how do you solve this? Here I'm assuming that this q is positive, because if q is not positive, it doesn't have solution. So the first, I'm assuming that here, if q is positive, at least not negative, right? Since we have something squared here, then we will have here x plus p is equal to plus minus square root of q, right? Now if I just take p to the left hand side, then we will have here x is equal to minus p plus minus square root of q. Okay, now we are going to see this, how to do that. Actually, there's one geometric description of this phenomena here, what we are doing here. All right. Here, for example, if you're given this completing the square methods, for example, x squared plus bx. All right, our expression is here x squared plus bx. Okay, we are just going to use this idea to complete the given expression to the perfect square. So what should I do? What should I add here? What should I add here so that this expression becomes perfect square? Perfect square means the square of an algebraic expression. So we will have here something x plus p squared. Okay. So as blocks, for example, here, this x squared plus bx. What does it mean? This x squared plus bx means here we have x times x plus b. Right? Here, the width of this rectangle is x, and length it is x plus b. So x plus b, we are multiplying this. So this is area, x times x, that's x squared, right? And the width, it is x, length here it is b, bx. Now if I just divide it into 2 halves, b over 2, right? And I'm just splitting this into 2 parts and leave it one here, and this part, just put it here, because it's also with this x, right? It's also x. So now something is missing here to have a perfect square, right? Because I'm going to build or transform this into a square. Assume that actually we use unit blocks to make this, what is this? That's area or anything or any shape, right? When I just try to make this a perfect square, something is missing here. So I should add something so that it becomes a perfect square. What are the dimensions of this piece? I need something here, right? If I just write here, as you see here, the length, what is the length of this block, building block, is b over 2. And how about here is also b over 2 because of this, right? Actually, I need to add this small piece. And what is the area of this small piece? It is b over 2 squared. That's a just geometric description of this phenomena here, all right? Admits one Viajana. In example, Ropi, good to see you.
Yes, sir. Thank you.
All right. When we get back to the campus, I will buy coffee for you every week. And seeing your eyes and face here, it motivates me a lot. Otherwise, just talking to the wall, I don't see anybody's face. Okay, solve the following equations. Let's start with this equation because it's already in a ready form. because it's already on the left hand side. We have perfect square, right? X plus 2 squared, something squared. We call this perfect square. How do you solve this? As you see here on the right hand side, we have 16, right? And the 16 is positive. That means that it has solution. So to do this one, the first step is question A, that x plus 2 is equal to plus minus square root of 16. And just take 2 to the left hand side, then x will be equal to minus 2 plus minus square root of 16. Or I can just evaluate this. We know the square root of 16 is, what is it? 4. Minus 2 plus minus 4. Now I can write the solution. This x is equal to, if it is plus, negative 2 plus 4, it is 2. Or x equals, if it is minus, negative 2 minus 4, that's equal to minus 6. Okay. How about this one in similar way? Something squared is positive number. Does it make sense? Yes. So we can solve this. It has solution. The first step, x minus 3 is equal to plus minus square root of 5. Okay, now from here, what is x? X equals, take to the right hand side, 3 plus minus square root of 5. Okay, but now here the problem is, how do you bring, if you're given any quadratic equation, into this form? Okay, that is a main challenge here. What must be added to each of the following expressions to obtain a perfect square? Now, is it a perfect square? No, it's not a square of any algebraic expression, right? But by adding something, we can have a perfect square. To do this one, we should just remember this formula, that a plus b. Actually, we call this perfect square. It is a square of an algebraic expression, right? So that's equal to a squared plus 2ab plus b squared. So for an algebraic expression to be a perfect square, it must be in this form, right? Then if it is in this form, I can write it as the square of something. So actually, I try to have something similar to this. In question A, x squared plus, what is this, 5? In the formula, we have 2. So this 5, I can write it as 2 times 5 over 2, right? X. This is algebraic manipulation. I just multiply by something divided by something. The result does not change, right? It is 5. Plus, so I have here in the form, I have 2, something squared, and here we have a times b. So I need here b squared, right? What should we add here to make the expression perfect square? I need to add the square of this number. That is 5 over 2 squared. So the question is, what must be, right? What must be added? So our answer is 5 over 2 squared. Or we can just write here 25 over 4 must be added to the expression so that it becomes a perfect square. Okay. How about in question B? A squared plus, we already have 2 here, 2 times ka, right? In the formula, we have 2. Yes, we have a squared. We have a. So what we need here, we need k squared. So if I just write k squared, then it becomes the perfect square. So it becomes a plus k squared. So what should we add to this expression to make it a perfect square? We should add this term, k squared. How about in C? Here we have c squared minus 4c, right? And I can write it as c squared minus 2 times c, right? In the formula, we have 2, right? And c squared, and our b here is 2. So we should add here 2 squared. If it is so, then I can write it here. Actually, they are not equal. So to make it a perfect square, we need to add these 2 squares. Dot, dot, dot. So actually the answer is 4 must be added to this expression so that it becomes a perfect square. Okay? So now we will use this technique to solve this quadratic equation. Solve x squared plus 8x plus 9 equals 0, giving your answer correct as 3 significant figures. And also this thing, I don't know, have you ever seen this? 3 significant figures. In short, abbreviated form of this one is, we just write it as 3s dot f. That means that significant figures, okay? After we solve this, I will give you some information about what we mean by significant big figures, because when you're answering the questions, you may be asked to leave your answer correct to a certain number of decimal places or a certain number of significant figures. And these things are not the same things, okay? So now I'm going to use this completing the square method to solve this quadratic equation. To do this one, first I have to bring this into this form. What is it? That is x plus p squared equals q. Okay. So here we have x squared plus, it's already 1 here, so we don't have to do anything. This 8, I can write it as 2 times 4 times x, because in the formula we have 2. Now I need the square of this number. So plus 9, right? So I need here 4 squared. If I just write here 4 squared, but actually we have here 9, right? So to get 9 here, I need to subtract 7 equals 0. What we did here is just a simple algebraic manipulation. Multiply something, divide something, add something, subtract something, but we are not changing, how to say, this equation. We are just changing its appearance. After all, it gives us the same solution. So here, as you see, 2 times 4, it is 8, right? 4 squared, 16, 16 minus 7, it is 9. As you see here, this part, it is a perfect square. And the rest take to the right hand side, so that we have this form. And this one is equal to x plus 4 squared. On the right hand side, we have 7. Okay, and we know how to solve this equation. That is x plus 4 is equal to plus minus square root of 7, right? Or x equals negative 4 plus minus square root of 7, right? What does it mean? It means that the first root of this equation is negative 4 plus square root of 7, and the second root is equal to minus 4 minus square root of 7. Okay. But in the question, it says that giving your answer correct as 3 significant figures. Also in the midterm, I'm going to ask this in this way, okay? If you don't know this, your answer may be wrong. Now here, I'm going to write this answer correct to 3 significant figures. So if you just evaluate this using your calculator, the first one, it is minus 4 plus square root of 7. When I just evaluate this, we will get this answer. Negative 1.35354248, blah, blah, blah. And when it is minus, we get this answer. Negative 6.6464575, and continue. Okay, because this is a rational number. So 3 significant figure means starting from the first non-zero, just keep 3 digits. Okay, it means this, starting from the first non-zero number. So what is the first non-zero number? It is 1. So starting from 1, just keep 3 digits. So I need to keep these 3 digits. And after that, we know that we need to round off. If the next digit is greater than 4, I should add 1 to this, like to the previous digit. Otherwise, just drop it. Okay, so it is less than 5. I just erase this. That is the answer. And I need to write here, this one is correct as 3 significant figures. Okay, and how about this one? Starting from the first non-zero digits, the first non-zero digit is 6. 1, 2, 3. and after 4, that is 5. So I need to add 1 to the previous digit, right? So when I'm rounding off this number, delete this and also delete this. Because of that 5, it should be 65. 3 significant figures. Okay. Just example for significant figures. For example, if we have 0.0125678, for example. How do you write this correct as 3 significant figures? Starting from the first non-zero digits. What is the first non-zero digit? It is 1. So I should just keep the 3 digits starting from here. And after 5 it is 6 greater than 1. So that's equal to 0.0126. And 3 significant figures examples. How about if we have like 7, 5, 6, 1, 9, 8, 1, for example? Correct as 3 significant figures. So starting from the first non-zero number, it is 7. Just keep this, right? After that, it is less than 5. So that's equal to 7, 5, 6. And it's not a decimal number, right? It's before the decimal point. So 1, 2, 3, 4. We just write zeros for these numbers. That means that significant means important for us. These digits are important, but decimal digits is not important. And when do we use this? Like, for example, when we're counting the population of countries, for example, right? What is the population of Cambodia? We don't say that 13,250,000 something, right? We just said around 13 million. So that means that we are counting everything in millions. That is correct as 2 significant figures. Okay, with this less than, I mean, it's just a 2-digit number. Okay, if it is like 3-digit number, the population of, for example, Russia or Canada or USA, at the time we just write the population correct as 3 significant figures. Just keep the first 3 digits and after that round off. All right, continue. Other questions using the technique, completing the square method. Solve the equations, but here using the completing the square method. Okay, so first we have to write this in standard form. Standard form is ax squared plus bx plus c. How can I write this? Multiply both sides by -1. -1 times 0, it is 0. So here -1 times -x squared, it is x squared, right? And here we have minus 16x plus 63. That's equal to 0. Okay. Maybe here, some questions you may be able to solve this by factorization, but some questions not. And why we are learning this method here, are we going to use this method? Sometimes you may use this, but now after this, we are going to learn how to use the formula, and direct also you can use the formula, okay? You're just learning different methods, which one is suitable for you. You can just pick any method and use it to solve the problem. Here, how do you solve this problem using that completing the square method? Again, we have to separate a perfect square from this expression. In the formula, we have 2, and 2 times 8 is 16, and x. I'm not changing anything, right? It's just simple manipulation. And as see here, this number is 8. I need 8 squared here. What is 8 squared? It is 64. So I need here 8 squared, right? But here we have 63. So I need to just subtract 1 equals 0, right? 2 times 8 it is 16. 64 minus 1 it is 63. We didn't do anything here. As you see, these first 3 terms gives us a perfect square, that is x minus 8 squared. And take 1 to the right hand side. Here we have 1. And from here, what is x minus 8? X minus 8 is equal to plus minus 1, because square root of 1 is 1. From here, x equals, take to the right hand side, 8 plus minus 1. So I can just write here, the first solution is 8 plus 1, it is 9. And the second solution is 8 minus 1, it is 7. Okay. How about example B? Here we have x squared plus 2 times 2 times x plus, I need the square of this number, it is 2 squared, and here we have 4 equals 0. Right? And you see here, 4 plus 4, it is 8. 2 times 2, it is 4. And the first 3 terms is a perfect square. It is x plus 2 squared equals, take 4 to the right hand side, here we have minus 4. Now, do we have any real number whose square is negative number? We don't have any such number, right? So this equation is never possible. If you just substitute any real number and square this, we never get, what is it, negative number. That means that this equation has no real roots. Okay. Okay, now actually we'll just talk about this a bit later. This is a special name actually. We call this discriminant. All right, guys, that's all about completing the square method. Now we have around 7 minutes left. Now I want to start using that formula and finish today's class. Guys, I'm going to close, okay, and I'll send a new link. We'll just have 10 more minutes, and after that I'll finish our class.